Hello, this is Mr. Huff, and I want to talk about the decision matrix. Let's say that you are brainstorming with your team, and each one of you has come up with 10 ideas each. So you have 30 ideas to consider and to identify which one is going to be the best solution. So, what you would normally do in this case is everybody brings what they believe to be their best ideas to the table, but you need a fair way to assess each idea and decide which one is best. Otherwise, you may end up going with the person who's most popular or the one that talks the loudest. I don't know. You will end up with a solution, choosing a solution that is not possibly the best one. So these are the main steps we're going to look at right here. There's three main steps in creating a decision matrix. One, identify the criteria. If you have a design brief, you should have your criteria mostly listed for you already, but there may be some other criteria and constraints you want to consider. For instance, how long is this thing going to take to build? Is this going to be hard to build or easy to build? Things like that. So you also need to list the best solution ideas that you want to evaluate. Usually you will have 3 or 4 or 10. So most of the time in Introduction to Engineering, you're usually looking at about maybe 3 to 5 designs that you're evaluating, but I want you to go through this process just so that you can be certain that you are choosing the correct one. And then you have to create a grading scale, and it's up to you. I've got a suggestion. I really like how they do it in here, and to kind of go through that and grade these. Some ideas for criteria. You can think about the cost of the materials, how much it's going to cost to develop it. I don't know if that's really applicable to you guys for stuff we do in here. We might consider manufacturing cost. How much are your raw materials going to take? How long is it going to take you to build? Is it reusable? What about geometry? What about connections? How is that going to work? Cleanliness, resilience. I like resilience. Is it going to be durable? Is it going to be testable? That's a really great question. Durability and lifespan is another idea. Development time is kind of the same as over here. Is it going to be the appropriate size? Does it meet company or class standards? Is it going to be safe when you're done? And is it something you can build? Do you have the materials you need for it? And is it going to function? Is it going to solve the problem? Okay. This is just a sample list. A lot of times you are only going to be looking at about 4 or 5 ways of comparing these. You usually don't have to go to like 15 different things. It's usually scoring just with a few attributes. Okay. Grading scales, a real simple way is make it a yes or no question, and you choose 1 or 2. Usually what we do, oh, that's a really terrible picture. Usually what we do is we use a grading scale like this, where you say 4 is the best and 1 is the worst. So if if it really is strongly, let's say it's what you're looking at is the time to build. If it's going to take just a little bit of time to build, then that is a number 4. It's the best. If you think you're barely going to be able to finish it within the timeline, then that makes it the worst solution. So you would give it a 1. So you just score each one, 1, 2, 3, or 4, and it doesn't have to be, one in each category. You just score it the way it is, where you think it fits. Is it the best? Is it almost the best? Is it a little bit bad, or is it really bad? Okay. I don't suggest using 5 because you end up with the center one on a lot of them. So make a choice. Is it toward better or is it toward worse? All right. And then you put that together in a decision matrix. So another thing too, they bring out, you can come up with your own ideas for this, your own ideas. That's fine. So this is an example of a decision matrix. So they're comparing 3 criteria. They have 6 ideas. I would give them more clear names instead of idea 1, 2, 3, and 4. So you would give them names that kind of help you remember what it is you're talking about. So the things that they're looking at, how much is it going to cost? How complex is it going to be? So the more complex it is, the lower the score. And development time, the longer it takes, the lower the score. And then you have a total for each row. Okay, so let's look at what the little bubbles say. So these are from your brainstorming sessions. And then these are usually from the design brief, and they can also be other things that you guys think about as because you're going to have to produce this solution, right? So it needs to be something like the development time might be something that's not part of your criteria, but is something that's important for actually producing your prototype. Totals, you just add them up all the way across and give each one a score. You need to have a clear winner. Okay, don't go for ties. If you have a tie, add another criteria where one of them is obviously stronger than the other. The idea with the highest total is the one you're going to do. And what this does is you can have 2 ideas from 3 people, so you have 6 ideas total, and this is going to make it where the person that has the best idea, even if they're quiet, you're still going to choose the best idea. All right, and then here's your scales that you use. All right, so that's how to do a decision matrix. It looks just like this. This is real easy to do in your notebook. All right, that's all.